So this week, our new topic is talking about the polynomial division. So let's see some example quickly. These some examples. So when we do some math homework, when we do the math homework, let me give some maybe early example quickly. We say 3 plus 5 divided 2. You guys most of the time do like this way, say 3 plus 5, you got 8 divided 2, so you got 4, right? Most of the time do like this way. All right. So in algebra, each numbers is not given a number, they give you some variable, right? So by 3 plus 5x divided 2. So we cannot 3 plus 5x, right? We cannot combine. So what do we need to do? We can do this. We can do 3 divided 2 first, and plus 5x divided 2 separately. Just like here, just like this 4, we can do different way. We can do, say, this equals 3 divided 2 plus 5 divided 2, right? Separately. And then you can get is here is 1.5, here is 2.5. You plus together, it's still got 4, right? Don't change it. The only thing when you do the math, you do the 3 plus 5 first. Because of this, you can combine. But right now, when you change it to the variables, you cannot combine. You have to do it separately. Just like you can do this one first. 3 over 2 first and 5 over 2 second. The same here. We do 3 over 2 first, 5x over 2 second, separately, right? You can do this way. Similar to our polynomial division. So when there's a multi-terms on the numerator, we know the fraction. When you do a divide, the top part called numerator, right? This is denominator. This is numerator. This is denominator. Right? So when the numerator have multi-terms, divide one term, we call only one term. We use the same methods as here. Because of they including the variable here, they cannot combine. So what we need to do, we divide separately. That's the mechanism behind. So like this one, this example. First, in the numerator, they have 3 terms, and denominator only 1 terms. We cannot combine this one first, right? Because they are not like terms. They cannot combine right away. So what do we have to do? We do it separately. Let's do each of them separately, right? We can do this one. We have to rewrite. We'll rewrite. If they don't divide only 1 term, we can do this one quickly. Right? So like this term, we easily get like our homework, I skip the part say 1 term divided 1 term. You guys we learn this one in the exponent part. So when they are variable, it's the same, the base is the same. We can easily do the divide and simplify it, right? Like this one. So you can coefficient part divide by itself. Here is 3, right? This part 5 minus 2, so you got 3, right? Coefficient divide by itself, coefficient 12 over 3. This part is got a 1, right? The last one, 3 divided 3, you got a 1. What about the last? X divided x squared. So you factor 1 out, so you got x here. So this is the simplified version, right? You can quickly get out of here. All right, so polynomial term divided 1 term is easy. You can do these kinds of separately. What about divided 2 term? All right, let me go to the second line. When the denominator is 2 term, 1 polynomial divided 1 term, we can use the previous. What about divided 2 term? 2 terms like this one, x squared, this is x squared plus 12x plus 12x. Divide x plus 5. What do we do? How we do this one? Yeah, some people say, okay, why we not do like this way? We do it separately. Do it separately will be like this. X divided here. Did you feel it makes sense? What do we try to do to find a solution? We make it simplify, right? Math work. We find very complicated kinds of situation, make it simplify and find a solution. But if we do like this way, we make it more complicated, right? So we cannot do like this way. We don't like to do like this way. Make it more complicated. No, we are not. So what do we need to do? How we do divide this one when there's 2 terms in the bottom? So let's go back to see another example. When we do the math, how we do the math in the math part. Let's see this example. Say 3,006. This is a call thousands, hundreds, tenths, ones, right? When you divide 3, just like 3666. When you do a divide 3, you can just like what we earlier doing. 3 divided 3, so you can 1220. Because of these thousands divide here, you can get it here quickly, right? Thousands divide 3, hundreds divide 3, 6 tenths, there are 60s divide 3, and zeros divide 3. So you can get this one quickly. So when they divide 13, that's a 2 terms. This is just like a tenth and threes. How we divide this one? So you guys maybe used these methods earlier, right? So we know this is thousands, hundreds, tenths, ones. We sequence them, right? And this is sequence them already, tenths, ones. So we first step, what we need to do is we compare the first two and first two first, right? We compare these two. This have 2. We have to find these 2 first. So you try to find a number times this number very close to this 36, right? So you got a 2, 26, because 3, 39 is over it. It's 1, 13, too far away from it. Only got 2 is most close to 36. You compare these 2 numbers, right? 13 and 36. You find a number times this number very close to this number, but not over this number, right? So you got 26. So you 106. So you find another number, most close 106. So you got maybe 8. We know you have answer here, so we already know this 8. So you can got a 104, right? So 3 times 8, you got 24. 1 times 8 plus 2, you got a 10. So left 20. So you got a 0. You got a 1 here. So you got 13. And finally left is 7. So you can say 30 divide 13 equal 281, and remainder is 7. So, or you can say 660 divided 13 equal 281 plus 7 over 13, right? This is called remainder, right? So let's see the back mechanism behind. So when there's 2 terms, we first find the 2 terms, compare them, find a number most close to them, and then continue to do the work, right? And finally, until this number is less than the denominator. So this is the remainder. This is the quotient, right? This is the numerator, denominator. So you got the numerator, denominator, and find the quotient and remainder. So use the same mechanism for our polynomial division situation. Let's see this one. What do we need to do this one? What do we do this one? Okay, let's do this one. All right, so use the same mechanism, same process. So first we sequence length first. So x squared, what is sequence length? So here is degrees of 2 and degrees of 1 and degrees of 0, right? And divide this degree 1 and degree 0 is also from sequence length. Just like the one here is thousands, hundreds, tenths, ones. So we do the same sequence length first. All right, so these two terms, we also find first two terms. Try to find a number times this one most close to here. So x times what close to x squared is x, right? X here is degrees of 1. We put above the degree of 1 here. So you can get x squared plus 5x. So actually you can see here is 36 minus 26. You got a 10 here. The same here we will do minus top minus bottom. Top minus bottom here, right? So here it became 0, right? Here it became 7x, 12x minus 5x or 7x plus 35. So okay, so we're gonna need to find another number times this one close, very close here. So we need 7 times what equals 70x, 7x, 7. So you can go 7x, 7 times x, 7 times 5. So remainder is 0. All right, so it means what? X squared plus 12x plus 35 divided x plus 5 equal x plus 7. It's much easier than this expression, right? We cannot do like this way, like earlier, do the one term in the denominator situation. So this one is much better, much better. All right, let's see. Let's go check it again. All right, let's check it again. So it means, let me erase this part. So erase this part. So what actually it means what? It means this one actually is this situation, right? Right? So let's check here. Let me use different color, check here. So this one divide this one equal this part. So let's check this one. X plus 5. This equal what? We learn this, right? We learn it, just learn it. That's good things. So this one equal x squared, 7x, 5x plus totally together is 12x and 35, right? So this part divide this one equal this one. Definitely makes sense. Easy way, right? All right, let's see second example. Can you guys take your homework, take your notebook out, do this one. Do the second one. How we do this one? Let me clean the screen. Save one first before I screen it. All right, take your notebook out, do this one. We know this one already. Divide x plus 3. How we do that? So first with sequence length. This is degree 2, degree 1, degree 0, right? Divide x plus 3. Divide this one by this one. So first, with these two terms, also check first two terms. So x times what equal x squared, x, right? So you can go to x plus, so this x time here. So you got first x squared, second is 3x, right? Top minus bottom, top minus bottom. So you can got here is 0, here is 4x left, right? Plus 12. All right, we find second one. X times what equal 4x? Times 4, right? So you can 4 times x equal 4x. 4 times 3 equal 12. So remainder is 0. So it means this one equals what? Equal x plus 4. Right? Let's check it. So something divided x plus 3 equal x plus 4. So let's check it. This one equals what? We can quickly get out of here. X squared, 4x, 3x, so go to 7x plus 12. Right? We do a backward situation. So this part divided here, of course, you equal here. So remainder is 0. Remainder is 0. All right, let's quickly do this one. Let's do this one. 6x squared plus 7x minus 7 divide 2x minus 1 with sequence length. All right, sequence length as well. So first, 2x times what equals 6x squared? 3x, right? 3x. So 3x first time here. So you can got 6x squared minus 3x. Top minus bottom, top minus bottom. So you can do 10x minus 7.
Class is over, dude.
You class is over. Okay. Oh, let's finish this one. You guys want to go to the gala? All right.
No, there's this Chinese party, and it's happened like
10 minutes ago.
9 minutes ago about that time.
Okay, so let's do this one. Finish this.
And it's
So
still
what's
happening
next?
right now.
Okay, so here time what? So need to find 5, right? So you can 10x, 2 times x, and minus 5. So left is negative 2, right? So it means 6x squared plus 7x minus 7 divided 2x minus 1. This equal what? Equal 3x plus 5. What's the remainder? Remainder is negative 2. Remainder negative, we need it right here. We need to still copy this one right here. Understand? Okay. So this is the quantity. This is the remainder. This is the numerator. All right. All right. Let's do one more thing before we. I know time is too quick. Let's do this one. Let's do this one and then done for today. All right. See this one. This one. Let me zoom in a little bit. Make sure you guys can see it. All right. See this one. This one. So what we need to do? Firstly, we need a sequence length. Sequence length. Sequence length. First, this degree 3, this degree 1, this degree 0, right? Degree 3, where degree 2 is gone, right? So it's missing. So we need to leave a space for them, all right? But degree 2 is missing, so nothing was there. So degree 1 is negative x. So we need a sequence length first. All right, be careful. Make sure if they are missing of the degree 3, 2, 1, 0 is missing, leaves the space for them. Divide 3x plus 2. All right, so we find a term time this one exactly match up here. What? 3x squared, right? We need a 3x squared, the degree of 2, top of degree 2. So you can got what? You got 3 times 3x squared times this one. So you got x 9x cubic plus 6x squared. Top minus bottom. So here actually is 0, nothing there, right? So it became, here is totally gone. Here is negative 6x squared. Copy down second one. So 3x times what? Match up here. Negative 2x. So negative x times all this term, you got negative 6x squared minus 4x. Top minus bottom, top minus bottom. So you can get 3x, right? Negative x minus 4x, so positive 3x. So finally 1. So here just need 1. So can match up here, right? So left over is 3. Okay, so this result is 3x squared minus 2x plus 1. And remainder is 3. So this is quantity. This is the remainder. This is the dividend. All right, that's all for today. Let's have 5 minutes earlier since we didn't have break. So let's talk a little bit more next week. All right, have a wonderful week and enjoy the gala. See you later. Have a good day, everyone.
Bye.
Bye-bye.